In this video, we will take a look at the section on discrete random variables in the text. The text provides an example of DiCarlo motors, and in this example, they establish the discrete probability distribution, the expected value or the mean. They find the variance and then determine the standard deviation for the distribution. We're going to work through that step at a time. If you don't have your worksheet set up like this, you should pause the video and take a moment and put in these headings. We've talked about how to do superscripts in class. We've talked about how to insert special characters in class. You can find those. You'll have some problems. You'll just have to think through them. When you insert the mu, for example, it's going to change the font. So when you try to type this right parenthesis, it's not going to look right. You'll have to work through and solve that, get it to look right. Same way, when you make this an uppercase 2, you may find that it affects the size of the f here in f sub x. So you'll have to work through that as well. All right, the text provides us with some information. The first column, DiCarlo Motors took 300 days and evaluated their car sales. And during that 300 days, the minimum number of cars that sold was 0, and the maximum was 5. So we'll take that range between 0 and 5. Then they counted the number of days that each sales volume occurred. So 54 days, they sold no cars. 117 days, 1 car. 72 days, 2 cars. 42 days, 3 cars. 12 days, 4 cars. And 3 days, they sold 5 cars. For a total, let's go ahead and draw a line here. For a total of sum all of these. 300 days. So now we can calculate the probability of each volume of car sales over the 300-day period by taking the number of days in which a particular sales volume occurred and putting that over the total number of days that were observed. I'll make that absolute so I can copy it down. And I'm just going to double click on my autofill node here and copy that down. That creates the discrete probability distribution for DiCarlo Motors. Now we need to calculate the expected value or the mean for the distribution. That is simply x times f of x equals x times the f of x equals 0 in that case. Copy that all the way down. Set those so that they have the same number of decimals. I'll go with 2. Once we have that, we can go ahead then and sum that. And that gives us our expected value of x, which is also equal to, put that cursor between those two equal signs. This is how I overcome the problem of a changing font with a symbol. I just go ahead and put the next value in, then insert the symbol between them, which is also the mean or mu of the distribution. So we found the expected value. Now we need to calculate the variance. There are 3 steps to accomplishing that. First, we need to take x and subtract it from mu for each instance. So we'll take x and subtract that from mu. I'll make that absolute. Now when I sum these, I'll get close to 0 since we have low and high values here. Well, not so close to 0, but an incorrect number. So when calculating the variance, I always square these values. So I'm going to take x minus mu and raise it to the second power. That takes out the effect of the negative values. I'll go ahead and calculate the variance for each volume of sales, and that is simply, as the equation above shows, x minus mu squared times f of x. I'll just copy that down. I'll go ahead and draw a line there and sum that. That gives me my variance. Put in a value here. Square that. I'll put my cursor in the front, insert symbol. I want sigma there, insert. I'll go ahead and grab that 2 and set it to be superscript. Okay, that gives me the variance, and I'll copy this, paste it here, and go ahead and take the 2 out. So I want the standard deviation, which is simply the square root of the variance. So I'll use the square root function in Excel of the variance. And that gives me the standard deviation. Those are the steps you use to create a discrete probability distribution through observation, and then to find the mean, expected value, variance, and standard deviation of the distribution.